Hey guys, I'm anxious to show you this new tool that I made. What I'm using this is a Weller soldering iron. It's a 40-watt soldering iron that I modified to fit into my chuck here. And what I'm doing is I'm using it to put these inserts, these brass inserts. These happen to be little bearing holders for an Orbot 3D printer. My son came to me the other week and he said, "Hey Dad, I think I'd like to build a printer." I couldn't have been more proud. So he's working on building an Orbot. But in any case, I wanted to show you, this is really cool. This is heated up right now, and these brass inserts, the neat thing about these is that they're fairly inexpensive. You can get these at McMaster Car. They're only about 11 or 12 cents a piece, where normally inserts are quite expensive. And it just works so cool. Now I have this set up in this fixture here that I usually use for tapping small holes, but you could go ahead and rig up something similar and just put it in a drill press. It would work just fine. Neat thing is I have the stop set, so the stop is set level with this, and that way it'll only put it in so far. Now this is a big, huge, really big insert, so it's going to take a little while to heat it up, but you can see it going in already quite well. And there it's seated. We'll do another one. One thing you want to be really careful, you know, these soldering irons are only about 20 bucks or so, but get the one with the light just so that you can see that it's on and remind you. Also be really careful if you have small, kids around, because it's, for some reason, it looks like something they could grab onto. But yeah, this works really slick, and you'll be shocked at how well these things hold in place. I did some testing with it, making it a little fixture to see how much force it would take to pull it out, and I was blown away by how well these things hold in there, and I think you'll really like it. This one needs to be set just a hair more. Now I'm setting this in PLA here. These little holders here that I printed are just PLA, but it works well in PLA and ABS. You'll see I have a bunch of these are little pieces for my new extruder design. So we'll go ahead and put these. These are 832. This is a number 8 right here. This insert, and these are 832 inserts going into some ABS. These are little ABS pieces, but I also have some PLA on those 832s also. If you just put a little tiny bit of pressure, it goes down really nice, and makes an unbelievable bond in there. You can see where it's serrated. The serrations there keep it from spinning. And I'm just putting a little bit of force on it as it's going down. Again, you want to be really careful. This thing will burn you bad, just like a soldering iron, of course. Okay, I'll let it cool off, and I'll go ahead and change out. You can actually, you can make or buy these. If you have a lathe, you can make them for real cheap. Otherwise, they're about 15 bucks. But they make different inserts for different different sizes for different inserts. Now this one here, you can't get them for the, it's kind of weird, but you can't get, they don't have, I haven't been able to see them for the 8mm. So what I did is I took a 1/4 or a 1/4 inch soldering iron insert, and I just turned it down. It had enough meat on it that I was able to turn it down from the 1/4 inch to fit this 8mm really well. So that's an option if you have a lathe. I'll go ahead and I'll unplug it, let it cool down, and change out, and show you some of the 832 inserts being put in. Alright, I went ahead and changed out to the 832. I'll go ahead and reset my height for this next operation, and it's pretty close. Just gotta lower it down just a hair. And again, this can all be done in a drill press quite easily. Goes in quite nice. That one wanted to come out just a little bit. The PLA, you don't really need to let it soak. Once it's in, you can pretty much pull it out. So that's it. And you can see there's a wide variety of these fasteners that are available. These I got from McMaster-Carr. Like I said, about 11 or 12 cents. You buy them in packages of 100. It's like 11 or 12 dollars, something like that. Incidentally, if you're not familiar with these screws, these fasteners here, these are fantastic. They're made, they call them, McMaster-Carr calls them screws for brittle plastic, and they're really fantastic also. If you just size your hole correctly. This is for a 1030, or let's see. Yeah, these are for like 1032 size hole. This is like a 832. And then this one here is for like a 632. Pretty small. But yeah, those are fantastic also for fastening options. Well, I hope you liked it. I've been playing around with filament and bought a lot of filament, and just wanted to share something with you that I've discovered. Moisture, of course, makes a huge difference in the print quality, and I had a spool of filament that I got that was very wet. It was obvious in the print. You know, there's tons of steam coming out of the nozzle, so I knew it had a lot of moisture in it. What I have right here, this is a laboratory vacuum chamber. And I did some testing using desiccant and pulling a deep vacuum on this to see how it affected the filament and would help dry it out. And sure enough, as I suspected, it did help considerably. This is another one that I just converted a pressure pot. This is actually a Harbor Freight pressure pot. And what I did is I just went ahead and put a vacuum gauge on it and a valve. These really don't do anything. When it's got a deep vacuum on it, it's just the vacuum itself that keeps it sealed up. One thing that's interesting that I didn't suspect would happen is that this thing will hold a deep vacuum for many months, as well as this one. This one I expected would, but this one I didn't think would hold a vacuum as well. And it's actually surprised me quite a bit. You can see here, I'll go ahead and open it up. You can see this one's already got a deep vacuum pulled on it. It's about roughly about 28 inches. It can do pretty easily. But I'll go ahead and this is the couple spools that I've got in here. This is the one that had a lot of moisture in it. But you can see here's some of the desiccant down in there. I have some of them. I've got some of the blue silica in there also, and that kind of lets me monitor how wet it is. because this desiccant, you can actually dry it. I put it in my powder coating oven, dry it out, and it can you know, refresh the desiccant so that it'll work again. But it is worked really well. It does definitely make a huge difference. Yeah, I go ahead and just use it for storage. You know, if I usually have more than these two will hold that I'm using at all times. But one thing that I do is I just keep it in Ziploc bags with a little desiccant bag, and that works really well. One thing, you know, I did some measurements on that spool before and after a treatment of just like 2 weeks, and it was actually less than 1 gram of weight, which is actually quite difficult to even measure. But 1 gram of weight, if you were to drip water on a table, it would only be about the size of a nickel. So not very much actual water at all. However, it does make a huge difference in the way of vapor. So anyways, just wanted to pass that along to you. In talking about this filament, it just brought to mind one other thing that I wanted to share with you. I don't know if you're familiar with this. Is a fairly new product here in the States. It's manufactured over the pond, I believe. It's called Color Fab, and it's sold by a company called printedsolid.com. They're right here in Southern California. So I went ahead and picked up a couple of these spools, and I've already done some printing with it. The stuff's pretty interesting. It's like a hybrid PLA. They call it a PLA-PHA filament, and it's got kind of a unique characteristic to it. It does print totally different. It seems to take a little hotter, a little bit more temp on the hot end also. But if you're looking for kind of a felty, more of a felt type of finish on the part, the printed part, you might want to play around with this. I'll show you. I printed a this is actually going to be on another video, but I'll just let you take a peek. This is a hexacopter that I just printed recently, and this green, this is total experimentation. These here are ABS, and I intended to do all the motor mounts in ABS, but just for the heck of it, these two here are PLA, and I just wanted to give them a try. But you can take a look. This one here is that green, this Color Fab spool, and it printed quite nice, but it's just got a weird kind of a felty texture to it. And it's not the settings. The settings were identical to this PLA right here. It just printed totally different. I just have this, this is just mocked up. Nothing's permanently fastened. These things are all just sitting here. But you can see the difference in the finish. And that's just because of the material, strictly the material that did that. Anyways, in an effort to test all the filament that's available, I thought I'd give it a try and see how it did. And for certain things, I can see it being pretty cool. But the spools are also noticeably smaller. They show the weight at 750 grams, so it's a little bit less than a normal spool. You can see the difference here. Here's your normal typical spool, and here's this spool. So you can see it's quite a bit smaller. I'd say maybe 2/3 of what this one is. Anyways, just wanted to share that. Alright guys, we're over in the electronics lab, and I'm going to go ahead and disassemble some of my extruders. Most of you have seen my worm gear design extruder, which actually worked out pretty cool. The problem that I ran into was that I had to run the current really high, like at max, on this stepper in order to get it to drive well in some situations, especially at higher speeds. Another thing too is that this part here is extremely complex in the design, and naturally I probably, you know, this I printed in ABS, but I would have had it made in aluminum, you know, in a production type deal. And it's just the complexity of this is just so much more, and quite often, as is the case, simple is good, in which case I ended up coming up with this design. And this, by the way, is the original hot end effector for on my Berry bot. And this thing has well over 1,000 hours on it, and just ran flawlessly. I'm really quite happy. Most of the problems that I had in the way of feeding never had to do with the machine. It was always the filament. And the biggest issue I had was the size of the filament, where it would have areas that were swollen or swelled to as much as 0.23 millimeter, in which case it would just not be able to even feed in through the tube that I used to have on my machine. But this design here I'm really happy with, and something that I think I'm going to go with moving forward. We'll go ahead and pull this all apart, and I'll let you take a look at exactly what encompasses this unit here. You know, I like these geared stepper motors that I've been using, and I've got many of them for the machines that I'm putting together now, and these are just a really great little gear motor. I've got them throttled back quite a bit on this design because of the having it geared just made it so much Alright, so this is pretty much the whole unit right here. And one of the things that I thought was kind of clever and works really well, so if I back this out all the way, you'll see what I have in here are these bevel washers, spring washers, and I have a whole bunch of them back to back. And the idea here is that this produces this spring tension on the roller, and it just does a really great job. It's roughly about 25 pounds of force that it's putting on the bearing, or putting on this movable part of the extruder. But you'll see it only has about a 1/16 or so, but that's all it needs in order to work very effectively. You can see this this here moves. This here's on a pivot and just slides back and forth, putting pressure from the bearing onto the knurled roller. We'll go ahead and pull this apart further, and you'll be able to see the part that I had with the inserts. This was the original prototype, so this one doesn't even have the nice brass insert in it, but you'll get an idea of the simplicity of this, and you can see the size of it, how tiny it is. This is really neat, and the weight is not very much at all. I can print at speeds of 200 millimeters a second with rapids of 500 with no problem whatsoever. Lately I've been printing at higher speeds than I used to. I'm getting away with 150 and just getting awesome adhesion in between layers. So you can see the parts here. It's really quite simple. There's not many parts to it. These I printed out of ABS, and it's just these two plates and this. So this is a case where simple's better. And you know, interestingly, the new part that I have designed for this is actually quite complex, and would be very difficult to machine. This is a case where you can have a printed part that would be very, very difficult to machine, CNC machine. I'll go grab the newer design and I'll show it to you. But you can see this is all it is, just the bearing, these two parts, and two aluminum plates. I'll show you the newer one that I have of this. You know, in printing these, I just kind of thought, originally I was going to machine them out of aluminum, just even for the prototype, and I thought, well, what the heck, I'm going to try making them out of ABS. And this is a really good example of where you can go ahead and make parts, you know, that are real usable parts, even in something, in a situation like this, you know, where this has actually got quite a bit of pressure pushing on it, and it just worked great. I had probably about, this unit here had about 50-75 hours on it, and my new one's got about over 100 hours on it, and they just have worked flawlessly. This is this one I printed out of PLA. This is the newer design. You can see it's quite different from this original prototype, and some of the things that are unique about it that would make it extremely difficult to go ahead and CNC machine is that you know, this is opened up here, funnel shaped. So as the filament comes down, if it's bent in any direction, you know, it'll still feed in perfectly and come through a very defined point here on the bottom. You know, CNC machining that would be, you know, very difficult to do. Not to mention, look at all the processes that you would have to set up in your CNC in order to machine all this stuff. You know, this is just a really neat part, and works just so well. I'm really excited about it. Anyways, I whipped a whole bunch of these out on my Platen. I was printing like 5 or 6 of them at a time. But yeah, it works really good. I'm really quite excited about that. Simple's good. Something else I wanted to show you and talk about, our buddy Sanjay, that's making these new hot ends. I got a bunch of them from him, and I'm going to do some testing. You know, just because I can build just about anything in my shop, sometimes it doesn't make sense, and I gotta say, Sanjay did a really nice job with these units. They look really clean. It's identical to the one that was on the original Berry bot, with one big exception, and that is that my aluminum diffuser here it had a Teflon tube that ran all the way down to where the thermal break was. So just about a 1/16 inch above the thermal break, you know, I've got Teflon tube. But as far as the quality is concerned, these are really quite beautiful, and I'm anxious to give them a try. Anyways, just wanted to share that with you. Coming up, we're going to have, I've got a bunch of other neat things that I want to talk about in future videos. One of them that was really a fun project was working on the hexacopter. That's going to come up in a future video. Also, talk about the first 1,000 hours of the Berry bot. Look forward to that one, because that's going to be fun. Anyways, I hope you guys enjoyed it. Keep printing.